Okay, you should be on assignment 513. We're going to start talking about how you graph inverse functions, specifically y equals, say, cosecant of theta. Okay. Now, there's only one thing you know about cosecant. Cosecant is the inverse of sine. That's all you need to know, because you know how to graph these already. Sorry about that little blip. Let's try this again. Sine x, right? So you already know how to graph sine. So pi, 2 pi. You know, sine looks like this. It goes up to 1, goes down right here, goes down to -1, and it's right here. It's back up to 0. Now, secant is going to be 1 over that, right? So when sine is 0, secant ends up being, or sorry, cosecant ends up being an asymptote, 1 over 0. Sorry about the inaccuracy here. When sine is 1, 1 over 1 is also 1. And then back to 0. 1 over 0 is undefined, therefore an asymptote. 1 over -1 would be -1. And then we're back to being an asymptote. Now we know sine is always positive in this area over here, the first and second quadrant, right? So if it's starting on an asymptote, it has to start at positive infinity. It goes down to where it hits 1, and then it has to go back up to positive infinity because it can't go in a negative land. Because it's not, this spot here is not negative, right? So one of our positive numbers is still positive. So you end up doing this, right? Now when sine gets to this quadrant, it's negative. So 1 over it will also be negative. So it ends up doing this. And then if we were to continue the pattern, and so both cosecant and secant graphs end up looking like this over and over again. Okay? All right, go ahead and pause this and then try problem number 1 on the back of 513. Once you're done trying it, well, I'll go ahead and do it for you. All right, problem number 1 says graph y equals secant of theta. All right, well, you know what secant is, it's y equals cosine theta's inverse, right? Cosine starts at 1, goes down to here, goes down to -1, back to 0, and back up to +1. So that's my y equals cosine theta. Secant's going to do the exact same thing that cosecant did, which is whenever cosine is 1, it's going to be 1 over 1, which makes it 1 as well. So it's going to have a dot there. Also, 1 over -1 is -1, so that's a dot there. And again, same thing here. But at 0, 1 over 0 is undefined, so that's an asymptote. Wow, sorry about how bad this is. There's an asymptote. And so what happens is the asymptote has to be positive still, so you end up drawing a little U-shaped thing here. Little arrows on the end. And I got a U down here. Ooh, yeah. And then I've got a U up here. And there you are. And that's y equals secant theta. All right. Go ahead and try number 2. When you get done, unpause this, and then I'll show you problem number 2. I'll show you the answer. I'm not going to do that step by step because I think you can figure that one out. We'll do number 3, and then I'll go ahead and do the problem number 3. And then when I get done with 3, I'll show you how to do 3. All right, so pause it. I'm pausing. Go ahead and pause it now, and then I'll put answer number 2 up, and then we'll do number 3 together after you've done it. Okay, so here's the answer for number 2. Here's the answer for number 2. Go ahead and pause it, and we'll do problem number 3 step by step. All right, let's try number 3. So we know about cosecant, it's the inverse of 1, it's inverse of sine, right? When graph sine, sine starts at 0, goes up to 1, gets back down to pi, down to -1, back up to 2 pi. That's where it's sitting. Now, cosecant is going to be same sort of situation, but I'm going to note that everywhere it's 0, I've got an asymptote. Everywhere it's a 0, I got an asymptote. Everywhere it's a 1, it's a 1. I got an asymptote. 1, it's a 1. So then I'd be sketching this, right? But I'm not done yet because I have this 3 hanging off the back end. The 3 says +3, so what do? Lift the whole thing 3. So instead of being at 1, I'm going to be at 4. Now, 3 plus infinity is still infinity, so I'm still going to go to infinity and negative infinity, right? So that's there. This one goes up to 3. Boop, right there. But now it's going to go down like that and down like this, right? And that's what the graph would look like. And if we had to continue the pattern, we'd have another one over here, etc. Okay? All right, go ahead and blow through 4. Do not start 5 without me. All right, I'm going to flip back to the front of 513. I have y equals tangent of x. I want to figure out how to graph y equals tangent of x. How do I do that? I try to remember what I know about tangent. If I grab my circular whirligig of death, or I look at something else like it, I get the following observations off of it. If I've got pi, 2 pi. I've got at 0, it's at 0. At pi over 2, it's at an undefined. So I think about it, go, wait a second. At pi over 4, it's at 1. At 3 pi over 4, it's at -1. And at pi, it's at 0. So it does this. Takes off, goes to infinity. Then it starts at negative infinity, comes on in to pi. And then if I look at the next quadrant, it's +1, and then it goes to infinity again. And then back into 0. Now what's interesting about pi is pi repeats every pi. So therefore the period, the normal period for pi is just, the normal period for tangent is just pi. Which means the period formula for tangent is a little bit weird. Instead of being 2 pi over omega, it's going to be pi over omega. That's the only real difference. That and the fact that the parent graph is going to look really wonky. It looks like this. Instead of going to 2 pi, it's at pi is when it's done. And it goes up to infinity. Then like this. Then hooks back into here. And it's done. Okay? So that's the way a tangent graph looks like, or a tangent parent graph looks like. All right? With that in mind, you should try number 5. Now, keep in mind, this period thing's weird, right? Okay. Now, after this, I'm going to shut down this video. I've got another video that explains better how to do this. There's one problem with this video. That is, instead of using omega, I used k that year for this letter down here, the letter that's in front of theta. So in the video, you hear me talking about k. K is omega. Okay, omega is a better way to write it. Okay, so I'm going to do problem number 5, but you need to try it. You need to try it first. So remember, parent graph. You're going to shift it left, right, up, down. We don't worry about stretching with tangent because it's going to infinity. So what's the top? What's the amplitude of it? Well, 2 times infinity is infinity, right? So we're wasting time. But if I have y equals 2 tangent x, there's no difference between that and the normal graph, except it wouldn't go through 1, it would go through 2. I'm hardly likely to notice that. So amplitudes and tangent graphs aren't all that important. Okay, but the rest of it is. You can shift them left, right. You can make the pattern repeat much more fast. Again, watch out because your period is got a pi on top, not 2 pi, and that is different. Okay? All right, with that in mind, I let you at it. Try problem number 5. And again, I'll have another separate video for just doing problem number 5. It's like 14 minutes long, just me doing problem number 5, 8 step at a time. All right?